Hi everyone. In the last section, we discussed about introduction to embedded systems as well as few applications of embedded system. And now this session is purely about the classification of embedded systems. So you can see this block diagram, that is the classifications of embedded systems. Basically, embedded systems is classified into 5 types based on complexity, based on generation, based on complexity, based on performance and responsibilities, and based on deterministic behavior, and as well as based on triggering, right? So this based on generation is classified into 4 types, that is first generation, second generation, third generation and fourth generation. And second, based on complexity is of 3 types: small scale embedded system, medium scale embedded system and large scale embedded system. And the third one is based on peripheral and functional requirements, like it has of 4 types. One is like real-time embedded systems, networking embedded systems and mobile embedded systems and small scale embedded systems. And fourth one is based on deterministic behavior. Only 2 types here: hard real time for embedded systems and soft real time for embedded systems. Then based on triggering is of 2 types. One is true triggered embedded systems and another one is time triggered embedded systems and another one is event triggered embedded systems, right? These are the basic classifications of embedded system. Let us discuss about each classification, right? First, let us move to generation. Based on generation, what are the types of embedded systems, right? First generation, second generation, third generation and fourth generation. So based on generation, in first generation, the processors were 8-bit microprocessors and 4-bit microcontrollers. Example, digital telephone keypads, stepper motor, control units, etc. And in second generation, same 8-bit processor and 4-bit controllers are replaced by 16-bit microprocessors and 18-bit microcontrollers. So examples here are data acquisition systems and SCADA systems, right? And the third generation and fourth generation here, the third generation is of domain specific process controllers like DSP, ASICs and the concept of instruction pipelining. And examples are robotics, industrial process control and embedded networking. The fourth generation is of recent development of microprocessors and microcontrollers, which has evolved during these modern days, like new concepts, that is system on chip, then reconfigurable processors, multi-core processors, co-processors, which are emerged into embedded market to add more powerful performance in the embedded systems. So the second example, smartphones, okay. So the second type is based on complexity. Here in based on complexity, first one is small scale embedded systems, medium scale embedded systems and third large scale embedded system. So small scale embedded system. So the small scale embedded system is just single 8 or 16-bit microprocessor or controller. Example, an electronic toy. Next, medium scale embedded system. It is a 16-bit or 32-bit microprocessor or controller like ASICs or DSPs. And large scale embedded system, it is a highly complex hardware and software built around 32-bit or 64-bit processor controllers, RISC processors, SoC, that is system on chip, scalable and configurable processors, right? And next one is based on performance and functional requirements. Here standard 4 types: standalone embedded system, real-time embedded system, networked embedded system and mobile embedded systems. Standalone embedded systems, this is stand alone, means independent. It is the independent system that do not depend on any other systems. Examples like MP3 players, digital cameras, video game consoles, microwave ovens and temperature measurement systems. It may either control or drive the connected devices, but it doesn't depend on any other systems. And real-time embedded system is nothing but it gives a required output with a specified time. So these systems follow the time deadlines for the completion of a task. Here we have two types. One is soft real time and another one is hard real time embedded systems. Example like automotive airbag control systems and flight control systems. And based on performance and functional requirements, here of networked embedded systems, four types. First, networked embedded systems and mobile embedded systems. Networked embedded system is related to a network to access the resources from one place, like connecting network that can be your LAN, WAN or the network. And it also connect by either by wired, it also get connected by either wired or wireless. Example like our home security systems, ATM machines and code swipe machines. So next one is mobile embedded systems. So it is very compact, easy to use and require few resources like portable embedded devices like mobile phones, digital cameras, MP3 players and personal digital assistants, etc. And next one is hard real-time deterministic. Based on deterministic behavior, we have two types. One is hard, two classifications. One is hard real-time system and another one is soft real-time system. A hard real-time system is really it must meet the timing deadlines without any delay. Like missing the deadline would cause serious failure to the system or user. Like a late answer is always a wrong answer. For example, I can say when a vehicle met with an accident, the airbag control system should operate immediately without any delay to safeguard the passenger. If there is any delay in the deployment of airbags, it will lead to the death of the passenger in the vehicle, right? And soft real-time system is the deadline is not strictly followed. Like missing deadlines for tasks are acceptable. A late answer is an acceptable answer. Like our ATM machine and our mobile phone, if any network problem, immediately we couldn't connect, but later we can connect. There won't be any problem. Anyway, we are going to connect, right? And same ATM machine, if there is any error, we couldn't fetch the money. And again, if we try, we may get it, right? So these are the two classifications. Next, last one is based on triggering. Two types. One is time triggered and another one is event triggered. Time triggered is activated or triggered based on the predefined task or preset time. Then such a system is said to be the time triggered embedded system. And event triggered, if the system is triggered based on some activity like change in temperature or change in pressure, such system is said to be an event triggered embedded system. So we have discussed about the classifications of embedded system in this session, and in the next session let us discuss about the structural units of embedded system. Thank you all.